everybody. Come in the room, come in the room, come in the room. It's Stacy here with another live video, math tutoring on demand. And I will share with you 5 divide and conquer math hacks everyone should know. Sometimes the word divisibility can feel like a mouthful. So let's think of it in a simpler way, like multiples, right? Ask yourself one question. If I skip count by a number, can I land exactly on the number that I'm testing? If the answer is yes, that means the number is a multiple of the number you're counting by. All right. Here are 5 helpful hacks using the prime numbers 2, 3, 5, 7, and 11. So I'm going to just switch over to my whiteboard so you can see. All right. So these shortcuts help you quickly decide if a number fits into one of these patterns. First, let's look at multiples of 2. When you skip count by 2, you get numbers like 2, 4, 6, 8, 10, and 12. These numbers always end in 0, 2, 4, and I'm going to say end with, sorry. Zero, 2, 4, 6. So if a number ends with one of those digits, it fits perfectly into the pattern of multiples of 2. For example, 48. Okay, it ends with 8. So we know you can reach it by skip counting by 2. That means 48 is a multiple of 2. Next are multiples of 3. The pattern goes 6, 9, 12, 15, 18, and so on. Instead of skip counting all the way up, there's a shortcut. Add the digits of the number together. If the sum lands in the pattern of multiples of 3, then the original number is also a multiple of 3. For example, take the number 1, 2, 3. All right. Add digits 1 plus 2 plus 3. Since 6 is the sum, the digits 1, 2, and 3, 6 is a multiple of 3. So the number 123 is also a multiple of 3. Now look at the multiples of 5. Okay? When you skip count by 5, you get numbers like 5, 25, and 30. Always end in 0 or 5. So if a number ends in 0 or 5, guess what? It is a multiple of 5. Okay? Now I know it looks like it's all one word, but you get it. I don't have that much room. Okay. So I'm going to say 0 or 5. For example, 45 ends with 5. So it is a multiple of 5. The number 120 also ends in 0. So it is also a multiple of 5. All right. Next, we have multiples of 7. These look 7, 14, 21, 28, 36. These happen to be hard for people to grasp, hard for students to get. Um, they're one of the last skip counting numbers that are used. And sometimes they don't even skip count. They skip count by twos, threes, neglected. But this is a very important. Take the last digit and double it. And then subtract it from the rest of the number. If it's a multiple of 7, then the original number is also a multiple of 7. For example, let's take the number 203. Oopsies. 203. Now, the last digit is 3. 3 times 2 is 6. And 20 minus 6 is 14. Since 14 is a multiple of 7, the number 203 is also a multiple of 7. Finally, let's look at multiples of 11. When you skip count by 11, 44, 55, and so on. Trick here. Add the digits in the ones. Add the digits in the odd ones. Then add the digits in the even positions and back the two sums. If the result is 0 or a multiple of 11, then the number is also a multiple of 11. So it can either be 0 or a multiple 11. So let's look at 121. The outer digits add to 2. 1 plus 1 is 2. The inner digits is 2. The difference is 0. 2 minus 2, which means 121 is a multiple of 11. There's this hack I really want you to understand and notice when working with factors is divisible by something. That means the number is broken into two parts, the divisor and the quotient. Okay, so together we're going to see that hold on. When a number is divisible by something that is broken into two parts, together multiply to make the original number. Okay, for example, 48. And let me just erase the board so I can show you this example, this bonus hack. That is very good to know. Okay. Let me do this for you. Hmm. Oh, okay. Got it. 48 is divisible by 6. Okay. Right here, I just did the factor tree. Not that you really have to break it down this far, but just know 6 and 8. Then 48 equals 6 times 8. The 6 is the divisor, and the 8 is the quotient. Okay. The 6 divisor, the 8 is going to be the quotient. Notice how this is the branch that is not being divided by. The factors that are not part of the divisor must belong to the quotient. So 2, 2, and 2 are the quotient, which is 8. Okay. Think of it like splitting a group into 2 teams. Okay. You got your 2 teams. One team is the divisor, and the other team, the numbers that are left must form the quotient. So whenever you find one factor, you automatically discover another one. And that simple idea is one of the most powerful ways mathematicians divide and conquer numbers. Okay. Let me also go this far. Say, for instance, you want to know what is 48 divided by 2 times 3 times 2, right? Say you split it like this. You split it 2 times 3, which is 6. 6 times 2 is 12. You divide by 12, it equals the remaining factors, which is 2 times 2 or 4. So without even like realizing it, once you break it down once, you always can tell just from the factors what the quotient is. The quotient is the remaining factors, the product of the remaining factors. And that's it. That's all I have for you. Oh, let me see. I think maybe, I'm not sure if you've been watching the whole time. Uh, if it didn't come through properly, then I guess I'll be deleting this. But thank you so much for tuning in next time.